So on to problem number 3 of semi-final number 2 at 2006 MIT Integration B is the definite integral from x equals to 0 to x tending to infinity of e to the power 3x minus e to the power x all over x times open bracket e to the power 3x plus 1 close bracket times e to the power x plus 1 close bracket. So this is one of those problems, and I'm just going off the cuff and say we're going to employ what people call the Feynman technique, but this is a technique that has existed for very long. It's the Leibniz Integral Rule. We'll see how we'll employ this technique to solve this problem. It's actually a very simple problem. It's not easy to solve it using Wolfram Alpha. I don't think you would get an answer, or your scientific calculator. But let's use this wonderful technique, the Leibniz Integral Rule, and see how we may be able to solve this problem. So the first thing I think we may want to do is express this part of the integrand into partial fraction. So this is same as 1 over x over 1 over e to the power x plus 1 minus 1 over e to the power 3x plus 1. You can confirm that. So this part here is equivalent to this part. Then we can now say, okay, there is an integer 3 here. We could now say, okay, this is the same as in. Our integral is the same as in, which is the definite integral from x equals 0 to x tend to infinity of 1 over x times, open bracket, 1 over e to the power x plus 1 minus 1 over e to the power nx plus 1. And this is a general form for which there is an instance when n equals to 3 that applies to our question. We're going to now use Leibniz Integral Rule. And for those of you who don't know what the Leibniz Integral Rule is, if you have the derivative of an integral starting from ax to another function bx, f x in the t domain. So the integral is in the t domain, but you have another dimension of variability in the x. So if you're differentiating in the x domain, then that is the same as substituting bx in t and differentiating bx minus fx ex differentiating the lower limit plus the same integral, same limits, but now we're trying to get the partial derivative with respect to x of fx t. Now, when bx and when bx is a constant, in our instance infinity, this tends to 0, this tends to 0. And so we do have our t here is x. Our x is n. It's kind of important. But now, if we differentiate if we differentiate in with respect to n, we get the partial derivative of the integrand because the limits are constant, right? And so the partial derivative means that this part will go to 0 because there is no n involvement there. So our integrand now becomes 1 over x times the partial derivative of negative 1 over nx plus 1. When we differentiate that, and this is d, not round delta, or round d. So this becomes the definite integral from x equals to 0 to x equals to infinity of 1 over x times x times e to the power nx over e to the power nx plus 1 squared. And this x and that cancel. So now we have an integral of e to the power nx over e to the power nx plus 1 squared. So that integrated becomes negative 1 over n times e to the power nx plus 1 from 0 to infinity. Limit for when x tends to infinity of negative 1 over n times e to the power nx plus 1. Since this part tends to infinity, so this entire limit goes to 0. And then when this is 0. When x tends to 0, it becomes 1 over n, 1 plus 1 here. So this tends to negative 1 over 2n. So we have a 0. This is 0. Minus negative 1 over 2n, which is now 1 over 2n. So the derivative with respect to n is 1 over 2n. And so if we go and integrate, in now is the integral with respect to n, obviously, of 1 over 2n, which becomes in is 1 over 2 natural logarithm of n plus c. But if we look at our problem, right? If we look at our problem, the way it is here, right? When n is equals to 1, this part becomes equal to this part, and this entire integral goes to 0. In other words, I of 1 is equals to 0. So what happens is we can now clearly see that if I of 1 is 0 and I of 1 is a half log of 1 and log of 1 is 0, then it means that c is 0. So c is definitely 0. And so in is simply a half natural logarithm of n. But the problem that we're given, the integral from x equals 0 to x times infinity of e to the power 3x minus e to the power x over e to the power x times e to the power 3x plus 1 times e to the power x plus 1 is I of 3, because the n we see there is I of 3. So therefore the answer that was being looked for is half natural logarithm of 3. Now, I did take time to expand on this, but obviously within the context and within the bounds of In integration B, a lot of these steps would have been abbreviated to make the process shorter, but I hope you do understand the method. The goal here is to expound on how to solve this problem, as not to compete with the contestant. These are very challenging problems, but I think it's good to know the techniques for which one would use to solve these problems. So if you haven't subscribed to our channel, we do encourage you to subscribe to our channel. If you haven't liked the video, please spare a moment, like and share. So until next time, bye bye. It was great hanging with you.